Hello everyone. Thanks Enzo for the introduction. And thanks all for joining on this call. I hope you and your near and dear ones are keeping well in this pandemic situation. In this time, basically, we all, learn lots of new skill, and I am no exception to it. I was experimenting around Flow and finding out possibility of using Flow in my company project, and I also doing some research for one of my published book on Android and Kotlin, and I would be sharing my learning with you all today. So without further ado, let's start it. So why we should use Flow as an Android engineer or maybe as a Java engineer, which you are maybe familiar with Kotlin, you might be asking, why should I use Flow? There is already coroutine and there is also channel available, and of course there is great Rx Android or RxJava, the beast. So why should I think about Flow? So here is few points which I would like to share with you, and maybe you would convince. So coroutine is more around structured concurrency, and it goes. It does not go well with managing stream of data. It's not just uh, it can't manage the stream of data, and it is more time taking if you would like to achieve just with the pure coroutine. So many times you simply need to manage stream of data, but something asynchronous, which you would like to do as a in your non-blocking thread. So that's where Flow comes in a picture. It has got that same power, but then there is Rx, and Rx is very rich in terms of operators um, and a lot of other features are there. It is already proven, people are using in production since years. So these are the reason people would like to stick with Rx, but Rx has got learning curve as well. So thinking from a newbie perspective, Rx has a quite a good learning curve. And flow is cold. So we're going to talk about what is cold and hot stream in a bit, but these are some of the argument for adopting Flow. And there are few more points. So Flow goes very easy in terms of integrating with live data, and if you are using Android architecture like view model and all those stuff, it goes really easy with the live data. And it has got a back pressure support. So what I mean by back pressure support is, uh, if you are familiar with Rx, you there is this disposable thing. While using Flow, you don't need to worry about disposing your subscription. Since Flow works with the suspendable function, it automatically takes care of it. So here is the coroutine will come, and Flow are built on top of the coroutine. So you don't need to worry about back pressure. That's one more plus point. Also, it has got multi-platform compatibility. So Flow is written in pure Kotlin, and Kotlin is multi-platform. So imagine you are writing an API or something in your iOS which using shared code mechanism. So you can get benefited by Flow as well. And then I think dev community was literally missing something like this, which is purely written in Kotlin, and they can just bring their entire application into fully Kotlin stack. And I was initially talking about that Flow is cold. So here is more about what is cold and hot stream. So there is channel. Now channel is hot. So when I say hot stream, that means even if you are not consuming the data would be continuously produced. So I feel there is bit of a overutilization of the resources. And then with Flow, it is cold. That means it only start emitting the data when you use the collection. So there is a collect operator which is known as a terminal operator. Until and unless you ask for collecting the stream, it won't emit the data. So that's the difference between hot and cold stream. Hot is like eager emitting. It will just keep on emitting data even if you don't consume it. But cold stream is, it will only emit the data if you demand it. So that's the fundamental difference. Okay, so if we want to start with the flow, how do I start? What's the first step I should take to start using the flow? So flow comes as a typical dependency in Gradle along with the coroutine. So you don't need to add any extra dependency in your project. Just add coroutine, and if it is an Android project, and add the coroutine Android as well. So by adding these two dependency, you will get the all the flow API in your code base. Now imagine there is list of strings. Now how do I treat this list of string as flow? So to convert this list of string in flow, what you will do is you will simply use flow as a lambda function and then write emit and then whatever is your property or object, and it will just convert everything into flow. So your list of string is converted into flow. Now there is this little extension function. So we know Kotlin is all about beautification and syntactic sugar. So there is this as flow extension function which is written on iterator class. So if any iterator can be converted into flow just by calling this as flow function. On top of that, there is also a flow of function. So what if I just want to convert anything into flow? Or other than iterator. So for that, I would use this flow of function which takes argument of type t and then convert anything into flow. And flow needs to be collected. We'll learn about collect operator in a bit, but keep this in mind. And then there are these various operators in flow. So we'll start with the simple operator first, and then we will understand few of the really interesting operator which flow offers us. So operator, why we have operator work on the data which is emitted, and it help us to transform them before they are actually collected and used. So that's the main job of operators. Imagine there is this piece of code, we call it a function called flowing river, which ultimately continuously emitting some sort of data. We call it water is, imagine it, there is some simple data class which holds some sort of value in your application. So we specify a return type as flow of type water, and then we provide a body which is a lambda style function. I say flow, and then into as a lambda parameter, I will put my while loop and then basically an emit function. So emit function is the key. Until and unless you emit, you can't receive anything. So emit is the key. And how do I collect it? So there is a flowing river, and then on top of that, we just add a collect operator. Collect operator receives an extra argument. It can be named anything, value or response or whatever you need, but it will receive the same data which is emitted, and you can do whatever you want to do. Here I am simply printing it, but it can be anything, sending something on a view or maybe doing further processing. Then there is a famous map operator which I think very widely used. So there is a flowing river, then we map it. So map simply transforms the data. So if you emit string in map, you can transform to any other thing based on your logic. So here I am translating into something else. So map transforms data into something else, and then using again a terminal operator which is collect, we receive that value and we process that value further. So that's the whole relation and philosophy of collect in along with your flow. I'm again saying until and unless you collect it, you cannot receive any emitted data. Then there is a filter operator, which is also very basic operator. It doesn't need any more or detailed explanation. So we have map operator. We can change it further to filter operator. So there can be chaining. So those who are familiar with Rx, they can easily relate to this. And then there is a filter operator. In filter, it requires a Boolean expression to process. If it is true, it will send the data further. If not, it will skip that data. That's simple. And then this gets collected further using a terminal operator collect. And then here we are just simply printing it. So those are very simple map and filter operator. There are few complex operator as well which you might want to use. This is something called buffer. So imagine a situation where both emit and collect, they take some time to execute. So imagine emit is taking 1 second of time, collect is taking 2 seconds of time. So collect is a costly operation in your application, and it is taking time. But flow is sequential. So what will happen? They emit the data, something get collected, a new data is emitted, a new data is collected. This is the flow. That's why it is called flow is sequential. And buffer can be a great help, and they can reduce the overall time. We'll see how it can help us to reduce overall time. Basically, they internally use a concept of channel while emitting the data, and then while you collect it, they uses another coroutine context. This is how the entire buffer operator works. We would try to understand it in with some sort of infographics. So let's say data 1 is emitted, the data 1 is collected. Now imagine data collect operator is taking more time, and meanwhile the new data got emitted. So buffer operator will respect time what collect operator needs and will not provide a new data to it until unless the collect operator is finished. After collect operator is finished, it emits the new data from the buffer operator. So this is how it goes. And meanwhile, any new emits can be just keep going into the buffer. Buffer will hold those emitted values and only send it to the collect operator once the collect operator is finished. So that's the core about buffer operator, how it looks in code. So imagine there is a download video function and you are emitting some sort of data. So I'm using delay function just to simulate the entire situation. So we emit value, we got delayed further, we emit one more chunk of data, and so on. So we keep on emitting data on some certain delay. At the end, what would happen here? If imagine I'm not using buffer operator and I'm simply using collect, then when I did this test run, it took around 8 seconds to complete this entire flow. And then when I use buffer, it simply reduces the time because your emission will take place on another channel, and then your collection will take place on another coroutine context. So that's where the time get saved, and I got to finish my task roughly 4 seconds. So you can see whatever time your emit function is taking, that can be saved if you use buffer. But you don't need to use it in every case. Only use it if there are any delays happening in your emit, or if emit is a very time taking task, then only use the buffer. In normal scenario, we won't use buffer. Another interesting operator is combine. So when you are dealing with multiple flow, this combine operator will help. So what I mean multiple flow is, let's say there are two functions which are returning flow and you want to work on both the flow because there is a requirement in your application. So you can combine the result of two flow using combine operator. So name is pretty logical, and the emission happens in parallel and you can bind them. It allows you to transform the emitted value as well before you finally collect it. So we'll see the same behavior with some more infographics to make it easy in terms of understanding. Let's say there is emit 1 and emit A. So there are two parallel flows going on. One is emitting number, another is emitting some alphabets. That result is collected further using combine operator. Now there is this emit 2, which is taking slightly longer time than the usual, but emit B is finished early. So what would happen in this situation? Combine usually picks up whatever is the latest result available in both the respected flow. So the result would be a combination of collect 2 and B. Now imagine meanwhile there is another emission happen from emit C. Now emit 2 is still going on. So the result would be it takes the latest value of emit 2 and a new result is generated which is called 2 and C. So this is the result. Because emit 2 was going on while emit C was emitted, it refers to emit 2 and it generates a new result. Similar, if this problem is extended further, now let's say emit 3 is happening, but emit C is going on. And as you can predict, it would be result of emit 3 and emit C. And then if emit D is happening, it will be result of emit 3 and emit D, because emit 3 is still going on and it is latest on the flow 1, and on the flow 2 latest was emit D. So the new result should be 3 and D. Again, it's time to look into the code, how we can actually do that. So imagine there is this function, we call it get unit values, which returns us some sort of flow. There is another function, we call it get ingredients, which also returns flow. And now our requirement is to merge them and get a combined result. So how do we use combine? So here we say combine operator. So there is this main function called get unit values. I am again slightly adding delay just to mimic the actual scenarios. And then I call combine operator. I pass another flow, get ingredients. So this is how you combine two flows. And then it generates a value. You can transform this into anything. I am transforming this into a string, but it could be your data class or anything. You can pass it to some other function based on your requirement. So you can utilize this space to transform your data or bring it to the form in which you need, and then ultimately you collect it. And then again, after collection, maybe you would like to pass it to your view to display it on a list, or maybe to some sort of detail screen. You can do whatever you want after you collect it. Similarly, there is a zip operator as well. This is similar to what Rx has, and it combines values emitted by two separate flow. But there is a slight difference in the way combine operator works and zip operator works. It will not emit final value if the corresponding emit is not found. So imagine there are two flow. If flow 1 has emitted the value but flow 2 hasn't, then it won't be creating any result because it is expecting the corresponding emit to happen. If you understand with the infographic, let's say there is emit 1 and emit A, so you get result as A and B. Similarly, emit 2 and emit B, you get result as 2 and B, and so on. But now imagine there is this emit 4 and nothing get emitted from the other flow. So this result will not be collected. This thing you have to keep in mind while you use zip operator. So mostly it would be your even number of flow emission. If it is an odd number of emission, some emission would miss. Mostly it would be your last emitted data which would be missed and won't be collected. And this is how you use it. So instead of combine operator, use a zip operator and then just pass on your another flow and get the result back. You can again transform your result to whatever you need, and at the end it got collected. Okay, so this was the introduction for basic operator and how you can use flow. But these are all the best scenarios which we consider, and in this year 2020 we have learned enough lesson why we should plan for worst. So let's say what flow has to offer when it comes to error or exception handling. So basically flow offers you a mechanism to handle your exception runtime problem when your emitter or collect or any other operator goes nasty. Let's see how it works. So there is this function which, let's say there is a flowing river and there can be some sort of error. So I have written some logic where if the dam capacity is 50 and the water level reaches to there, it should just throw an error. So I can use try and catch basically to handle the exception, and then I can either throw the exception from try or can just listen whatever is happening inside try. And if try throw an error, it will ultimately come to a catch block. You will get instance of exception. This is a typical try catch what Kotlin is offering us. It has nothing to do with flow. And then we receive the final result in a finally. It can be optional, but this is not good in terms of code structuring, or this looks little ugly. So there is a better way which Flow is offering, and there is a catch operator which they introduce. So catch operator cannot be just placed anywhere. There is a concept called exception transparency, and this catch operator will catch all the exception which is happening preceding to that. So whatever is happening before catch operator, it will catch all the exception. Sounds good? So let's say if on each, in this example, on each is throwing an error, then the catch will caught that error. If there is a map operator or filter or any other operator, whatever is throwing an error, they will get caught by the catch. Now there is a slight glitch in this approach. If you think further, what if there is error in the collect itself and something goes wrong and collect is throwing an exception? Will that be caught? So answer is no. For that, you slightly need to change your implementation, which is called a declarative approach, where you move your entire logic out of the collect and move it to some other operator like on each or something. So if you see, compared to previous example, I have a println statement in catch collect, and I'm moving into on each operator, and then there is a catch operator below it. So I don't need to worry that my collect will throw any exception or not. So I have smartly moved my logic into some another operator, and then I can just call the collect function freely. Okay, is there any way I come to know about how, when, and where the flow is completed? So the answer is yes. Flow provides you two different ways to be aware of when the flow is completed. The first is called imperative collection. We basically call again try, catch, and finally, and at the end finally will be called, and you got to know that flow is finished. But we are not satisfied with this syntax, and as I said before, this looks ugly. So there is this on completion operator introduced by Flow, and this on completion you can again easily relate with the Rx. You will get notified here when the flow is finished. Now on completion has something interesting in it. If you observe, there is that parameter called cause. So when the flow is finished, and you will receive this cause parameter. If this cause parameter is not null, that means there is something wrong. There is some error happening. That's why you have some value in cause. And if the cause is null, that means there is no error, flow completed without any error. Okay, so we talked enough about basic flow, how it looks in Android. That's what we are interested in. So let's see what we need to do if I'm an Android developer and I want to use Flow. So I have taken a small use case for this. Okay, and the goal is to create a small application where I would be using some of the concept like architecture, component, means live data, and view model along with the flow. And in original example, in original application, I was achieving everything using Rx, but now I want to migrate, let's say, from Rx to Flow. So what else I should do if I want to use Flow for my application? So I have kept the example very simple and covering one base case scenario and one error scenario. So imagine there is a function which you have written in Rx, which returns a kind of a single, and then you get the response back. This get converted into like this, what is new in this is a suspend function is introduced, and then there is a return type which is changed. So we don't need now single or observable or anything. We just use a simple type which is called Recyclist Response. Now, in this repository implementation, I'm using repository pattern to make an API call. This is how it looks in Rx Android. So I return a single type of recipe. Further, I transform that data into something else as per my application need. I use some operator to get the data what I need. I have some sort of error handling inside do on operator, as you can see in the code. And if this has to be converted into flow, what it will look like. So this is how it would be changed. You change the return type to flow of recipe, then you convert your simple data into flow of recipe. This is the function which I have created because flow of was giving me some strange error. So I just add a wrapper function on top of it and then simply emitting the data. And at the end, do on error becomes catch. So I do the same thing which I was doing in do on operator. I do the same thing in catch operator. So this was the repository bit which I did. Now, if I think of a view model, so this is how my view model was looking when I was using Rx Android. So I was subscribing my repository call on this, and then I was showing a loader and I was doing error handling. And at the end, I was disposing it. If something goes wrong, if user moves on to another screen, I just dispose it. If I change this to flow, how it would look like. So this was the new code which got generated after I used flow. And this was the first change I did. I converted everything into live data of recipe, and then the entire bit got changed. So there is this on start. On start will tell you when the flow is started. It is something like do on subscribe. It is similar to that. And then there is this on completion, which will notify you when the flow is finished. There is this sketch. I added this error handling just to transform my HTTP exception into more meaningful business exception. And then I just call as live data. As live data is an extension function provided by, I think, one of the KTX library we have for live data. So there we have got this extension function. And from this, my entire flow can be converted into live data. And this live data is, of course, observed on the view layer, which would look something like this. So we have a fragment, recipe detail fragment. I have this view state our fragment, which is nothing but the abstraction part of the way I do error handling and the way I show progress bar. You can find it in the main example, which I would be sharing after the session. And then I created a view model. I am using Coin for the dependency injection purpose, and the view created function. I simply call my API and then observe it. So I call view model to whatever is the function. I pass the required data to it, and then I observe them. And once my observer has the result, I show it to the view using show recipe detail function. Similarly, if that was the success scenario, now what if there is an error scenario? So as I said, inside view state aware fragment, I have written some abstraction layer for my error observer and progress observer. And this is just I'm overriding that value and do whatever I want. So I can do error handling in my own way, maybe in a different activity, because I can override them. So I can slightly tweak the behavior according to the screen I am. It's a bit of a flexible. So that was pretty much on the main code side. And then what if I want to secure my code by writing some unit test? Is unit testing really easy in Flow or not? Let's evaluate. So to set up your unit test, it's pretty much simple as you do in your existing project. I'm using mock k for the library. So I say I'm mocking the repository and the service layer. Sorry, this is the repository test, so I'm only mocking the service layer and not the repository class, because that's under test, which I shouldn't mock. And then I just set up my mock annotations. So I just initialize my mocks, I initialize my repository, and then further, here is a test I add. So I mock the behavior of the actual API and return some dummy response by using this co-every function. Co-every function is a function which can help you to mock anything which is inside a suspendable function. If you are familiar with the mock k, the typical every function won't work for your suspendable function. You have to use co-every for that. So it is for that. And then here is a bit. We simply say run blocking test and then recipe repository dot search recipe by ID and first. So in actual code, I was using collect as a terminal operator, but it could be first as well. So let's say I call first, I get the result back, and simply I assert. So whatever is my expected recipe, which I might have defined in my test data, and then the recipe class, recipe object, which I received as this repository call. And that's it. This is pretty much for the success scenario test. It's key thing only one. You just need to write your actual code inside a run blocking test, and then that function would manage everything. So there is a coroutine test dependency which you need to add, and that would do the job for you. Let's see how we can assert if there is any exception. I was actually using JUnit 5 while I write this application. So I have removed but unnecessary stuff. So it would pretty much look like a typical unit test. So let's mock the behavior. If there is an API call for get recipe by name, I would throw an exception called no internet exception. And then I would use assert throws. So this is the exception, or this is the function which is part of JUnit 5 library. And I would use run blocking test one more time. I call my actual function inside it. And then this is how I assert whether the exception is thrown or not. So I say assert true, and exception is instance of no internet exception. And if it is throwing the same exception, my test would pass. Otherwise, my test would fail. And that's why I would come to know if anything is missing. Then there is this one more useful extension function, which I think I should share with you. So there is a FlowOn. Now, if you can relate everything with your Rx, there was a function called subscribe on and observe on. So similarly, there is a FlowOn function for us provided by the Flow API, which is quite similar to subscribe on. It is basically used to change the context within the flow. So by default, your flow will run in your coroutine context. But if in case, if you want to switch the flow in between your flow or collection is happening, you can use FlowOn function to switch the flow. And main thing to remember is when you use FlowOn, the FlowOn function will only be applicable for your preceding operator. So anything below FlowOn operator won't be applicable for the context which you are passing in FlowOn. If you see the code, maybe you can try to visualize it more. So here is a piece of code. I have called FlowOn function at the end. So I'm saying I want to execute this flow on a IO thread, and it will offload everything which is a blocking kind of a behavior to an IO thread, which is a non-blocking thread. So this is how it would be managed, and anything above FlowOn operator will be executed in IO context of your coroutine. There is slight variation which FlowOn provides called FlowWith. Now this is very typical function you may not use in your day-to-day application, but this was interesting and worth sharing. So it is used to change the context within the given block and set of operators. So what do I mean by given block and set of operators? And let's see that, and it does not affect anything outside that block. So if you see, I don't have any exact example, so I just grab that example from the official documentation. So let's say there is this flow which is running on, and then there are two map operators, which is one is above the flow width, another is below the flow width, and I say flow width dispatcher.io. So the flow width will only apply that new context within that block. The previous, the precedented block and the subsequent block will not be affected by this new coroutine context. They will still be running in their original context, whatever we have specified, and only the block within flow width will get the new context. So that's the main difference between flow on and flow width. Something to remember if in case it encounters somewhere in your application. And then we saw as live data how it works. It is very great function, and it will keep your code beautiful. Otherwise, if you want to switch from flow to live data, you might need to write some ugly syntax, but this extension function is a great help. And there is also an extension function available in the same KTX library, where you can convert your live data into flow. I can't think of any scenario where you would be converting your live data into flow as far as the Android application is concerned. But again, if in case there is an operator, and there could be a scenario which I cannot think of or I cannot encounter in my application. But this is something good to know, that you can convert your live data into flow as well. So it's both the way, basically. And there cannot be any more limit on any of the extension function. You can build any other function which you want, and as per your need, while you use flow. So that's all from my side for the flow. You can find the source code in on this link. So Kotlin flow sample will cover a pure flow related example, and then there is a mill recipe app where I have pushed all the Android related example which I showed you today. It has two branches, and there is this readme as well, so you can go and have a look and try to fiddle around those repositories. Hopefully it would be helpful for you guys. Before I say bye, there are some key takeaways. So again, why we should use flow, or why should at least give it a go in your application. So it provides very focused set of operator. We know it is not as much operator compared to RxJava, but it's just matter of time, I guess. And sometimes also it helps if you have a focused set of operator which does the job. There is no need to you know add the heavy library which has a lot of other things as well, but not of your use. It is stable, so you can use it in your production application, and it has a really easy integration. There are lots of blogs available which you can refer to use flow along with your architecture component, mainly live data and view model. It is easy for unit testing. No basically bullshit around trampolining stuff, setting up Rx and everything. Just use run blocking test, and that will do the job. Back pressure support, this is very critical and important feature according to me. You just don't need to worry about disposable. We keep on forgetting that, considering a disposable while we work on RxJava, but I think flow is a great when it comes to the back pressure handling. And it's multi-platform, so you never know when you will unleash all the power of Kotlin as a language, right? You can leverage flow if you are using Kotlin in your API project or iOS application, or maybe native code. Why not? So yeah, keep the big picture in mind, and just go with the flow. That's it. Thanks for your time, and you can feel free to ask any question now on Slido, or reach out to me on Twitter.
Thanks, Hardik. I think we have a couple of questions. So they're gonna pop up in a moment. Just give me, yeah. So a couple of questions. Yeah, there you go. So if you can read it and answer it if you want. Yeah.
Yeah, sure. Let me load those questions. I can't, let me, okay.
I can read it to you if
I
you have
somehow,
an
yeah,
issue.
yeah.
Yeah.
Can you please me to read
Yeah.
the question?
So the first one is, do you use Flow in production? Would you recommend to replace Rx with Flow in complex projects?
Okay, so the project on which I'm working on is pretty big. We haven't started using Flow in particularly that project, but I would surely recommend. And the approach I would take is maybe I would try with the smallest possible module and see how it goes. You don't need to replace Flow in one go in your entire big application, right? You can take a step-by-step approach. So let's say simplest module can be a profile section or anything. It depends on your application, but I would definitely recommend in Flow. Even if it is a complex application, you can take the step by step approach. It is fully stable. There is also one more bit which you might want to consider. I don't know what exactly Rx operator you would be using, because Rx is full of operator. But if you are using simple operator like map, plat map, and stuff like that, I don't think there is any risk switching to Flow.
Cool. And second is pretty much connected to what you just said. So is there any operator of RxJava that is not available in Flow? I think it's probably specific to like a more complex, if you have an example.
Mm, so RxJava has this thing, right? So there is a single, and then there is a completable, and this kind of uh, calls. So I think it won't come as easily. So imagine you are using completable. So what do we what do we do in that case for Flow? I haven't particularly explored that way. What if you are using completable or something like that? But one thing I can say that with the single and observable, I have tried this two thing. That's what I use mainly in my application, and that come out very nice and smooth. But I'm sure the Rx has a lot of operator. Flow definitely don't have all the operator which Rx has, and it's matter of time.
Cool. Thanks, Hardik. Thanks so much. I would say just like it's been 6 months in the making, this talk. You contacted me like 6 months ago to
Yeah,
want to talk to the meetup. And then we had the lockdown, we had to do stuff, and finally we get
yeah,
back and we finally had this talk. So
yeah.
very
We
happy to have
finally
you.
made it, and I hope it would be useful for the
Yeah,
community and all
absolutely.
the
So
viewers.
yeah, there's a lot of interest in Flow and myself as well. We're talking about in my company to switch between from Java and Flow. The other things is that we still have some Java code, so
Yeah,
we first have to convert to Kotlin, and then we can embrace Flow fully,
yeah.
hopefully.
So this was more of a introductory session, and if we see interest of community, maybe we can have a much more dedicated session on how we can migrate from Rx
Mhm.
to Flow.
Oh, that would be cool.